The water in the Gulf of Khambhat doesn't look like the ocean in postcards. It's dark, silt-heavy, and restless, tides pulling like machinery, currents scraping the seafloor clean in one place and burying it meters deep in another. And then, on a sonar screen, something appears that shouldn't be there: straight lines, right angles, a pattern that looks like a grid. So what is the submerged city of the Gulf of Khambhat, and why doesn't it fit? Off India's west coast, in Gujarat, the Gulf of Khambhat forms a wide funnel where rivers pour into the sea and tides amplify into powerful currents. The accepted archaeological picture is cautious. Yes, sea levels rose after the last ice age, and yes, ancient coastlines were drowned, so prehistoric sites could exist underwater. But a fully planned city grid from the ice age is not an established conclusion. Here's the obstacle. This gulf is one of the hardest environments on Earth to verify anything visually. The water is turbid, the seabed is mobile, and much of what we see comes through remote sensing rather than excavation. If the strongest version of this claim were true, if those shapes are truly human-made and truly ancient, then it doesn't just add a new site to a map. It forces us to rethink where early complex societies could have formed, and how much of prehistory is now underwater. This mystery enters public awareness the way many modern archaeological controversies do, not through a museum display case, but through instruments. Underwater survey technologies, tools like sidescan sonar and sub-bottom profiling, can map the seafloor and the layers beneath it. In the Gulf of Khambhat, surveys reported anomalies, shapes that looked unusually geometric. The first interpretation, at its most careful, was simple. There are features worth investigating. The headline interpretation arrived almost immediately. A lost city under the sea. And then came the moment that turned curiosity into a timeline grenade. Reports that organic material recovered from the area, including wood, had been radiocarbon dated to extremely old ages, sometimes framed as reaching back into an ice age world. That's when the mystery truly begins. Because sonar can suggest shapes, but dates suggest history. And when the dates sound impossible, people stop asking what the feature is, and start asking what else we've gotten wrong. Let's lock down what we can say without turning speculation into fact. 1. The Gulf of Khambhat is a high-energy environment. Strong tides and currents move sediment constantly. Visibility is poor. This is not a calm, clear water dive site where you can simply swim down and film a wall. 2. Remote sensing surveys reported seabed anomalies. Sidescan sonar can reveal changes in texture and shape on the seabed, and sub-bottom profiling can hint at features beneath sediment. That's a legitimate first step in underwater investigation. 3. Some of the reported anomalies appeared rectilinear. Not. Maybe kind of linear if you squint, but enough to inspire interpretations of man-made geometry, including the popular phrase, city grids. 4. Objects and organic material were reportedly recovered. Many public accounts describe recoveries made using dredging or grab sampling, methods that can bring up material from the seafloor, but can also disrupt or mix contexts. 5. Radiocarbon dating was reportedly performed on some recovered organics. And the dates publicized were sometimes very old, old enough to power the before civilization began framing. 6. What's widely disputed is the context. In archaeology, context is everything. Underwater, it's even more brutal. If a sample wasn't recovered from a sealed, well-documented, in-place layer, it becomes difficult to prove it belongs to the structure you think you're dating. One more grounded point that matters for the bigger picture: global sea level rose dramatically after the last ice age, on the order of about 120 meters from the last glacial maximum to the mid-Holocene, drowning enormous stretches of coastline worldwide. That part is not controversial. What's controversial is whether this site is the smoking gun. Here is the single main anomaly, stated cleanly. Sonar images appear to show geometric, rectilinear patterns that resemble human planning, yet the only ice age dates widely discussed come from dredged organic samples whose connection to those patterns is uncertain. Why does this feel so compelling? First, because straight lines and right angles hit a deep mental trigger. We associate them with architecture, streets, walls, foundations. Second, because the ocean gives the story a built-in mechanism. We know coastlines moved. We know sea levels rose. Submerged ancient settlement is plausible in principle. Third, because radiocarbon dates have an authority that feels absolute. A number comes back, and suddenly the story sounds settled. But here's what this anomaly is not. It is not, on its own, proof of a city. It is not proof of advanced technology. It is not proof that humans were building Harappan-style grids in the Ice Age. It is, at most, a collision between pattern, environment, and the brutal rules of archaeological evidence. And to explain that collision, people split into theories. Theory 1. Mainstream/conventional. Natural features and displaced dates. The conventional view is cautious, and frankly, boring in the way truth often is. The grid could be natural, jointed bedrock, sand waves, ridges, paleochannels, features that can look rectilinear under certain sonar settings and processing. The very old radiocarbon dates could come from material that's old, but not connected to any structure. Rivers can carry wood. Currents can redeposit it. Dredging can mix it. You end up dating something ancient, without proving it belonged to a city. Key evidence supporting this view: the Gulf's extreme currents and sediment dynamics. The difficulty of in situ verification. The context problems created by dredged recovery. One limitation: it doesn't fully satisfy the question of why some sonar returns look so geometric without independent teams reprocessing the raw data and ground truthing the features. Theory 2. Alternative/speculative. Steelman, a drowned settlement from a lower sea level world. Now the strongest version of the alternative claim. Without the sensationalism, sea levels were lower. Vast coastal plains existed where today there is ocean. Humans lived along coasts because coasts are rich: fish, shellfish, river mouths, trade routes. So it is plausible that prehistoric settlements existed on the now submerged shelf. If the sonar geometry is real architecture, then sediment could have buried it quickly, preserving outlines under layers. The turbidity and currents that make diving hard could also be why it stayed hidden for so long. What problem this solves? It explains why we might see structured patterns underwater, and why we have so little, normal, archaeological visibility. One vulnerability: it requires direct proof in place: walls, floors, construction patterns, diagnostic artifacts in undisturbed layers, and replicated results from multiple independent teams. Without that, it's a story looking for a foundation. Theory 3. Hybrid/unknown. Real archaeology. Wrong age, wrong label. There's a third option that often gets ignored because it isn't dramatic. There may be archaeology down there: scattered habitation traces, later coastal structures, shipwreck debris, objects moved by rivers, and the sonar may be detecting something real. But the Ice Age dates may belong to reworked organic material not associated with the features. In other words, archaeology is present, but the timeline and interpretation are mismatched. What data would decide it? Controlled underwater excavation. Multiple radiocarbon samples from the same sealed stratigraphic unit. Sediment studies showing whether the layers were stable or constantly reworked. Raw sonar datasets shared and independently reinterpreted. Now we do what archaeology forces us to do: stress test the claim like an engineer stress tests a bridge. Dating: what exactly was dated? Radiocarbon dates organic material: wood, charcoal, bone, shell. It does not date stone. If the claim is a city grid, you need to date materials that can be tied directly to construction or occupation in that specific feature. Context: was the sample in place? Underwater, in place, is sacred. A wood fragment brought up by dredging could have come from a different layer, a different location, even a different transport pathway. Provenance: do we have a documented chain of custody? Coordinates, depth, method, sediment description, and lab documentation. Without it, a date becomes a number floating in a story. Method: sonar processing and interpretation. Sonar depends on settings, angles, and algorithms. Two teams can look at the same dataset and draw different boundaries. Replication: independent confirmation matters. If multiple teams scan the same area with different instruments and get the same geometry, confidence rises. If not, it stays a question mark. Alternative explanations: natural seabed features can mimic geometry, and human pattern recognition can turn interesting texture into streets faster than evidence can catch up. Magnitude check: do the data justify city grid, or do they justify anomalies worth deeper study? Those are not the same claim. After the stress test, what survives is not a neat conclusion, but a best fit reconstruction. Here's the most responsible narrative, separated into known, likely, speculative. Known: sea level rose dramatically after the last ice age, submerging ancient coastlines worldwide. IPCC AR6WG1. The Gulf of Khambhat is a difficult, high-energy environment where sediment moves constantly. Remote sensing surveys can detect anomalies, and this area has reported anomalies. Likely, the Gulf could contain underwater archaeological material, because ancient coasts were productive places for humans. Some recovered organic samples could be genuinely old, but in this environment, their association to any specific feature is hard to prove without controlled excavation. Speculative: that the rectilinear sonar patterns represent a planned city grid, and that the dated organics directly date that grid, reaching into an ice age timeframe. Why does this reconstruction fit the stress test? Because it respects what sea level science makes plausible, while acknowledging how underwater context can break the chain between a date and a structure. One unresolved thread stays open, and it's the thread that keeps this episode alive. If the sonar geometry is real and persistent across rescans, and if in situ excavation ever ties artifacts and dates to those features in sealed layers, the story could change fast. But until then, the Gulf remains what it has always been, a place that hides evidence better than headlines can reveal it. This mystery matters even if the Ice Age City claim collapses. Because the larger truth is already disruptive. Huge parts of human prehistory are underwater. Coastlines were home. River mouths were magnets. Migration routes hugged the sea. When sea level rose, it didn't just flood land, it erased maps. It also teaches a hard lesson about certainty. Archaeology isn't only about what existed. It's about what survived, what can be accessed, and what can be proven in context. Myths and cultural memories often speak of floods and lost lands. Sometimes they preserve echoes. Sometimes they don't. But geology guarantees at least this: many ancient stories could have a physical backdrop, because the land really did disappear beneath the sea. And in a world where sonar can sketch a shape without giving it a name, we have to be disciplined enough to say, interesting isn't the same as confirmed. Here's what's confirmed: sea levels rose, coastlines drowned, and the Gulf of Khambhat has reported underwater anomalies in an environment that makes verification brutally hard. Here's what's claimed: those anomalies are city grids, and the dates push them back before civilization began. If you had to choose, natural geometry, drowned settlement, or a hybrid where the archaeology is real but the age is wrong, what's your theory? Drop it in the comments, and if you want more evidence-first mysteries, subscribe and hit the playlist for submerged worlds and lost coastlines.